Hi, this is a bit of an unusual paper in that there's very theoretical stuff in there, but then we also went and implemented it, so there's a lot of implementation details. As soon as we started thinking about the proximity testing with privacy problem, we realized that it's a little bit trickier than we thought. For example, the obvious way of defining the ideal functionality is it's not secure. Also, the obvious way of constructing a solution, which is that the two parties send something garbled to the server and then the server compares them and announces the results, that is also not good, as you will see in the paper. Now, one of our key insights was that if you're going to implement all of this in the real world, it's all happening on top of a social network. So that's very important for us, both in terms of how we model the problem and the requirements, as well as how we implement the solution. That's the whole social keys part. We use that for shared secret keys between any pair of users, which you'll see in the paper. And then we give a number of cryptographic protocols for achieving private proximity testing. Another part of the paper is this whole location tags thing, which is this idea that there are all these electromagnetic signals all around us. There's, of course, Bluetooth and Wi-Fi, but also things like radio, or possibly even audio, which is, of course, not electromagnetic. But can we use all of these to derive some sort of fingerprints for every point in space and time? So we have some analyses in the paper. We've explored some of these, not all of them. And we also show cryptographically how, assuming that these location tags exist, how you can use that to do private proximity testing. And that basically boils down to a variant of the private set intersection problem. Now, we built all of this, of course. We have it running on our phones. It's on the Android platform. Let me quickly walk you through the steps in our application. It starts with the user establishing their key pair. For that, all they need to do is put in a password, and their public-private key pair is generated. They have to manually copy-paste their public key into their social network profile, although we're working on automating that part as well. Once they do that, they come back to our app, and then they have to decide a couple of simple preferences, like the proximity threshold and the update frequency. And once they do that, that's it. The app runs continuously in the background. It takes care of things like continuously monitoring changes in the user's friend's keys and testing for proximity every 5 minutes or whatever the update interval is. And whenever friends are detected nearby, it'll pop up a little alert in the status bar on top. And if you click on that, what you'll see is this. It's just a list of friends who are nearby. That's all there is to it.